Okay, sa video na ito, ituturo ko yung basic ng circuit, pati na din yung mga circuit elements natin at yung ilan sa mga electronic or electrical symbols na ginagamit sa pagdrawing ng isang schematic diagram ng circuit. So, simulan na natin. So first, what is an electric circuit? Or ano bang ibig sabihin kapag sinabing electronic or electrical circuit? So, an electronic or electric circuit is composed of individual electronics components or elements such as resistors, transistors, capacitors, diodes, and a power source connected via conductive wires or traces through which electric current can flow. So, a power source such as battery provides energy for the circuit to work. So, the components of an electrical or electronic circuit can be connected in series, parallel, or combination of series parallel connection. So yun nga, yung isang circuit is an interconnection of elements. These elements are classified into active and passive elements based on their capability to generate energy. So una, meron tayong tinatawag na active elements. Yung active elements are those which can generate energy. For example na lang, batteries, generators, and operational amplifiers or op-amp. Sila yung madalas na power source sa isang circuit or sila yung nagpo-produce ng power para sa circuit to work. Then mayroon tayong dalawang klase ng energy or power sources sa isang electric circuit. Ito ay tinatawag na independent and dependent voltage or current source. Example ng independent source is yung battery, which provides a constant DC voltage to the circuit without depending to the other elements. Then, sa dependent source naman, example na lang is si transistor, which provides current to the circuit depending upon the voltage applied to it. So meaning, dependent siya sa voltage na i-apply sa kanya ng another source, unlike sa battery na hindi. Kaya siya dependent source. So ito yung mga symbol ng voltage and current source natin sa isang schematic diagram ng circuit. And ito naman pag naka-specified na battery yung source. Then, a passive element is an electronic component which can only receive energy. So it can either dissipate, absorb, or store an energy in an electric field or in a magnetic field. So, hindi ito nagpo-produce or nag-generate ng voltage or current source. So, passive elements include resistors, capacitors, and coils, also called inductors. So, now, alam na natin yung mga circuit elements at yung mga classification nito. So, ngayon, tignan na natin sila kung paano ba ito ginagamit or paano sila nag-work sa isang circuit. So, unahin na natin si resistor. So, resistor is a passive two-terminal electrical components that implements electrical resistance as a circuit element. So, ito ay ginagamit para mag-reduce or mag-limit ng current flow, mag-adjust ng signal levels, or mag-divide ng mga voltage sa circuit. Resistance is measured in unit of ohms. So, sa mga ganitong klase ng resistor, gumagamit tayo ng color coding para ma-determine yung kanyang resistance value. So for example, itong 100 ohms. Ang first band niya is brown. Then second band ay black. Multiplier is brown. Simply means 100. Then yung gold or yung silver strip, yun yung kanyang tolerance. For example, gold, meaning plus minus 5% tolerance. Then ito, orange, brown, gold, meaning mayroon siyang resistance value na 330 ohms, plus minus 5% tolerance. And ito naman, brown, black, orange, gold. So meaning 10 kilo ohms or 10,000 ohms with plus minus 5% tolerance. So simple lang siya if memorize natin yung equivalent value ng bawat kulay ng resistor. Kung hindi naman, meron naman tayo mga apps na pang-calculate ng value ng resistor or mga chart sa internet. Ito yung symbol ng resistor sa isang schematic diagram. And ito naman pag variable resistor, meaning adjustable yung value ng kanyang resistance. Kagaya na lang ng potentiometer. So marami tayong klase ng resistor or yung mga elements na ginagamit para maglagay ng resistance sa isang circuit. Like ito, light dependent resistor or tinatawag ding photoresistor. Nagbabago yung resistance niya depende sa intensity ng light. So madalas ginagamit ito as light sensor sa mga robots, sa mga light follower robots or sa iba pang mga projects na kailangan ng pang-detect ng light. Then ito naman yung thermistor. Nagbabago naman yung kanyang resistivity depende naman sa temperature. Example application na lang nito is yung sa mga 3D printers. So ginagamit siyang sensor para ma-determine or ma-monitor yung temperature ng nozzle at yung heat bed nito. So next, capacitor. So a capacitor is a device that stores electrical energy in an electric field. So once the capacitor is fully charged, it can release all that energy in an instant. The capacitor is made of two closed conductors, usually plates, that are separated by dielectric material. Yung amount ng electrical energy na kayang ma-store sa capacitor ay nakadepende sa kanyang capacitance. So parang yung balde or bucket, so the bigger the bucket, the more the water it can store. Ganon din sa capacitor. So the bigger its capacitance, the more electricity it can store. So capacitance is measured in unit called farads or F. Sa capacitor, ang 1 farad ay masyado ng malaki. So ang kadalasang amount lang ng mga capacitors ay nasa usually microfarads, nanofarads, and or picofarads. So mayroon tayong iba't ibang klase ng capacitor. Example, electrolytic capacitor, mylar capacitor, polyester, and ceramic capacitor. So yung mga electrolytic capacitor, kagaya na lang nito, is tinatawag siyang polarized. Meaning meron siyang positive terminal and negative terminal, which is usually ito yung merong silver strip, yun yung negative niya. Then yung ceramic capacitors naman, kagaya na lang nito, is tinatawag siyang non-polarized. Meaning kahit magbaliktad lang yung leads niya sa circuit, so walang problema yon or walang kaso kahit magbaliktad yung pag-connect sa kanya. So capacitors are widely used in electronic circuit to perform variety of tasks such as smoothing, filtering, and bypassing. So for example na lang, pag sinabing smoothing, sa DC power supply, ginagamit yung capacitor para mag-supply ng current during yung fluctuation ng output ng rectifier. Bali nag-charge yung capacitor during pagtaas ng voltage output ng rectifier ng power supply, then magre-release yung charge niya during pagbaba ng output ng rectifier. So nagiging smooth yung output ng isang DC power supply. Nare-reduce niya yung fluctuation nito. So ito yung symbol ng capacitor. Yan pag non-polarized, and ito naman pag polarized, meron siyang plus sign. Then next, we have an inductor or minsan tinatawag na coil. It is a passive two-terminal electrical components that stores energy in a magnetic field when electric current flows through it. So unlike sa capacitor na sa electric field nag-i-store ng charge, yung inductor naman ay nasa magnetic field nag-i-store ng charge. So an inductor typically consists of an insulated wire wound into a coil around a core. So marami ding example ang inductor. Example sa mga inductive proximity sensor, electrical relays. So nagsiswitch yung relays using magnetic field na pinoproduce ng inductor or coil. Then sa transformer, which is the most popular application ng inductor. So by using a combination ng multiple inductors with a shared magnetic field can be designed into a transformer, which is ginagamit naman ng mga transformer para mag-decrease or step down or increase or step up ng power transmission. So inductance is measured in unit called henries or H. And ito yung symbol ng coil or inductor. Then ito naman yung sa transformer. Next is diode. A diode is a semiconductor device that essentially acts as a one-way switch for current. It allows current to flow easily in one direction but severely restricts current from flowing in the opposite direction. So meron kasing polarity yung diode. Yun yung anode, yung positive lead ng diode, and yung cathode, which is yung negative lead naman ng diode. Nakadepende sa polarity ng diode yung pagdaan ng current dito. So most diodes allows current to flow only when positive voltage is applied to anode. Kaya ito yung ginagamit pang rectify ng AC voltage into a DC voltage power supply, since nagkakonduct lang siya ng current in one way. So for example, since yung AC voltage ay nag-a-alter from positive cycle then going to negative cycle, then back to positive cycle and so forth. So using diode, na-eliminate yung negative cycle ng voltage ng AC. And naiiwan lang yung positive cycle which is needed para makapag-produce ng DC or direct current. So mayroon tayong tinatawag na forward bias at reverse bias. Forward bias is when a diode allows current to flow. Then, reverse bias naman is when a diode acts as an insulator and does not permit current to flow. So, marami ding klase ng diodes like Zener diodes, light emitting diodes, Schottky, and photodiodes. Then, ito naman yung symbol ng diodes. Yan, generic diodes, ito sa light emitting diodes, and Zener diode. So, then last, a transistor. So, a transistor is a semiconductor device. Meron itong tatlong terminals at kadalasan ginagamit ito upang mag-amplify or mag-switch ng mga electronic signals and electrical powers. Transistors are basically classified into two types. So, merong bipolar junction transistors or BJT and field effect transistors or yung FET or FET. Although transistors is not as obvious as a current or voltage source, ang mga transistors ay also active circuit components. This is because transistors are able to amplify the power of the signal, but considered as dependent source, since nakadepende siya sa voltage or current na manggagaling sa ibang active elements sa isang circuit. For example, dito sa NPN transistor na to, magsusupply siya ng mas malaking amount ng current from main source ng circuit if we apply a small amount ng current dito sa kanyang base. So, nakadepende siya sa current na i-apply sa kanyang base para i-allow niyang makapag-flow yung mas mataas na current. Kaya kadalasang ginagamit ito upang mag-switch or mag-drive ng mga load na nagre-required ng mas mataas na current using small amount ng current na manggagaling sa mga signals ng ibang electronic components natin, like sa microcontrollers, to drive or control DC motors. So, ito yung schematic symbol ng transistor. So, we have a bipolar junction transistor. Meron siyang NPN and PNP. Then, sa field effect transistor, meron naman siyang N-channel and P-channel. So, yan lang ang ilan sa mga examples natin ng circuit elements. I'm Jeff Magsino at sana ay may mga panibago naman tayong natutunan at mga kaalaman or idea na nadagdag sa atin at mai-apply natin ito sa pagbuo ng mga projects or mga circuits pa na ating gagawin. So hanggang dito na lang muna. Thank you sa panonood ng tutorial na to.